We're asked to write the quadratic equation y equals 2x squared minus 12x plus 5, which is often referred to as the general form of a quadratic function in the form y equals a times the quantity x minus h squared plus k, and this form is often referred to as standard form or graphing form of a quadratic function. And that's because h comma k is the vertex of the parabola. So one way to write the given equation in this form here would be to complete the square, but another method would be to find the vertex of the quadratic function using this equation, and then substituting the values of h and k into the equation, as well as the value of a. And let's use this approach for this question. So for a quick review, if we have a quadratic function in the form f of x equals ax squared plus bx plus c, then the vertex would have coordinates h comma k, where h would be equal to negative b divided by 2a, and k is equal to f of negative b divided by 2a, meaning to find the y-coordinate of the vertex, we evaluate the quadratic function at the x value of negative b divided by 2a. So using the given equation y equals 2x squared minus 12x plus 5, notice how a, the coefficient of x squared, is equal to 2, b, the coefficient of x would be negative 12, and c, the constant term, is positive 5. So now to find the vertex with coordinates h comma k, we know h is going to be equal to negative b divided by 2a, which would be negative 12 divided by 2 times a, which is 2. So simplifying, we have positive 12 divided by 4, which equals 3. So now we know that h is equal to 3, meaning the x-coordinate of the vertex is positive 3. And now let's find k. To find k, which is the y-coordinate of the vertex, we'll evaluate the function at x equals 3. So we're going to determine y of 3, which would be 2 times 3 squared minus 12 times 3 plus 5. So simplifying, 3 squared is equal to 9, 2 times 9 is 18, so we have 18 minus 12 times 3 is 36 plus 5. 18 minus 36 is negative 18 plus 5 equals negative 13. So now we know k is equal to negative 13. And this is all we need in order to write the given equation in the form y equals a times the quantity x minus h squared plus k. We know a equals 2, we know h equals 3, and we know k equals negative 13. And therefore we have y equals 2 times the quantity x minus h. H is positive 3, so we have the quantity x minus 3 squared. K is negative 13. Instead of writing plus negative 13, it's more common to just write minus 13. So this is the equivalent quadratic function in standard form or graphing form. Now, of course, to verify this, we could multiply this out. Let's go ahead and do this, and then we'll also verify it graphically. So to verify this is correct, we'll multiply this out. We would have y equals 2 times the quantity x minus 3 squared would be the quantity x minus 3 times the quantity x minus 3, and then minus 13. Next, we'll multiply here, so we'll have 4 products. So we have y equals 2 times the quantity x times x is x squared. X times negative 3 is negative 3x. And then we have negative 3 times x, which is another negative 3x. So we have minus 6x. Negative 3 times negative 3 is positive 9. Now we'll distribute the 2 and combine like terms. So we have y equals 2x squared minus 12x plus 18 minus 13, which does give us y equals 2x squared minus 12x, and then 18 minus 13 is positive 5. Notice how this equation is the same as the given equation. Another way to verify that our answer is correct would be to graph both equations and verify we do have the same parabola. So here's a graph of both equations, and it does produce the same quadratic function. Also notice how the vertex, this point here, does have coordinates 3, negative 13, which we previously found algebraically. And also notice how the y-intercept, which is the function value when x equals 0, would be positive 5, which is also reflected in our graph by this point here. I hope you found this helpful.